Hi, in this video we'll see area of a plane region. So we will try to understand what do you mean by area and how to measure area mathematically. So mathematically mean if we have an area, we will assign a well-defined number. So with that area, so that we will give logically. So firstly, let's try to understand what do we mean by area. So since it is from geometry, the concept of area from geometry. So I'll suggest you to restrict your mind in a piece of paper. So you take a piece of paper and so for example, what I'm trying to tell you, if you take a piece of paper, let's say, and then if I draw something a bounded region, so then we want to define the area of this bounded region. So how much place occupies inside this bounded region. So let's say boundary we called C, and this area we will calculate somehow mathematically. So now the measurement system so is developed by men. So that's why we need a logical development when we will measure something. Firstly, many years ago, when people started geometry, that time people did not use the numbers somehow. So they only have few concepts like points. They have the fundamental concept like a point. So of course, they start with a piece of paper. Say, on the piece of paper, you can draw many figures. So if you try to understand, the logic behind a figure, then you need to understand that figure logically. So now the question, what do we mean by logically? So logically mean we have some axiom, we'll write some axiom, that axiom has no proof, we just believe on that axiom and try to prove and try to discuss that figure. So that we will do here. So firstly, points people understood that time, ancient Greek time, and then they also believe the line segment, and also the angle is very important that time also. So now I will tell you why the line segment people believe, because they know how to measure the length of a line segment. For example, if I give 2 points A and B, then if I asked and let's say, so that time people have no idea about the number. Maybe right now in the modern mathematics, what we do, we'll take a ruler, so like this, and we will put the ruler from A to B, and maybe it will 3 centimeter, 4 centimeter. So what do you mean by this mean we have, a line segment. So here and then let's say I'll give another line segment, so then we'll understand better. So it's a CD, another line segment. That time people so basically did it by like this. So you have line segment AB and CD. Now see, so by looking these two line segment, it is clear that the line segment AB is smaller than line segment CD. So, but now recent mathematics, what we are doing, not just recent, the modern mathematics, 19th century. So people have a ruler. So we believe we have a ruler. Then we put this ruler here and also here. So then we know the length of AB, let's say 3 centimeter. And let's say this is 7 centimeter. And we know 3 centimeter is less 7 centimeter. So CD is a length is greater than AB length. So that is the idea. Somehow number system we connect here to study geometry in a very easy way. So that work is done by Cartesian. So somehow, but right now, there are many more tools. That tools we developed actually using more advanced language like topology, differential manifold, all the thing. But initially people had no idea about numbers. They just can see and they compare two figure, then they understand, okay, this figure is smaller, this figure is greater, like this. So in this video I will discuss, and I'll suggest you keep in your mind ancient time. So, you know, I'll suggest you not thinking very high, like a topology, smooth manifold. Just you think your mind is like a children and try to understand this lecture. Okay, so let's start the area. So how, so maybe, so we can start like this. So measurement mean you have to think and you try to compare. For example, if I give you, let's say this figure and maybe another figure, let's say this one. So then the area inside the red curve and the area inside this curve. So which one is greater? Clearly, if you see it, then it clearly the area of the red curve. So red color inside the red color, whatever you have area is the gray smaller than the area of the second curve. So this means this area is smaller than the area of this, right? So now okay, fine, that is fine. But see, suppose you know, you can imagine. So if two area, this situation, we have two area very near, so we can see both area together. But suppose you imagine some area is here. So in the plane on the earth, let's say this area is in India. And let's say one more area you have here, let's say it is in. So I'm taking here the red area here in the, let's say US. So now we try to compare which area will be the greater. So I mean, inside which curve there is more place occupies. So we want to understand that. So this means we need a common language that Indian people and US people will understand. So that is nothing but the concept of number. You know, numbers are the convenience way to understand the you know, the thinking of minds, or it is numbers are the bridge somehow, you know, the logical thinking. So if two people there are and both people are thinking, measuring something, then how you you know, let's say Indian people and Chinese people, if they are thinking how to measure the area, so Indian people use their symbol and Chinese people will use their Chinese symbol, but the logic behind both thinking will be the same. So that's why that abstract we need to write down here. So now, right now, people believe that okay, English is the that common language we can use in the all over the world. So let me first define. So what I am trying to tell you, that if we have a proper formula for area, then it will be good for understand. Universally, we can understand area. So that I am trying to tell you. So let me define here. So what do we mean by the formula? So let me take a rectangle. So I hope everyone familiar with the bounded region, whose standard figure, you know, like rectangle, square, circle, all these things. So let's say we have a rectangle called ABCD. Now see here, rectangle mean this angle is 90 degree and this angle is 90 degree and this angle is 90 degree and this is angle is 90 degree. Now here note that I am using the concept 90 degree, but that time people has no idea about 90 degree. They only know you have a, you know, the straight line, take a point. If you can divide equally two parts, then this part is 90 degree, right? This nowadays we are calling 90 degree, but that time people understand, okay, this is something right angle, something like this. Okay, so this it's a very important angle. So why it is very important? Because if you take a points here and if you want to find the shortest distance from this line, it will be this point. That angle will be this angle, like, you know, that's why it is important. So now what is the area of a rectangle? So there is no proof. This is just defined by people that if you take A, this length is A, this length B. So then the area of a rectangle will be something, the AV. So length and breadth, right? Something like this. Now, once we know, so how much place occupies inside the rectangle, it is nothing but take the product of two dimensions, length and width, right? Now, once we know the area of a rectangle, we can give the area of all, like a triangle, like trapezoidal, all the parallelogram, all the area we can define here. So firstly, we will first writing down the area of a parallelogram. So let's take a, so firstly, so if we take a, so this was the rectangle. So this is a, so this is nothing but this is the rectangle. Now a parallelogram, how it look like? So two opposites, the sides are parallel. So this way, so maybe better it will be understand. So the idea here, if you know the area for rectangle, then what will be the area of the parallelogram? Now one thing observe here, that why people use this breadth and width to define the area as the product of breadth and width, because that time people has idea how to measure the length between two points using the ruler. So that's why if you know these sides, if you know this side, then you can take the two number you need to take together. So there is a motivation why the product, we will take the product of breadth and length. There is a motivation idea. So okay, I'll tell you later, but right now let me define the area of the parallelogram. So what you do basically, now somehow we will use the concept of rectangle. So for to do this, firstly you can consider here that, okay, let's say our the base, maybe you can think a little bit extension this way. So now we will make it into a rectangle such that the area will be unchanged. So what we do to do this, so let me call it is A, B, C, D. So now I'm assuming that you can push this rectangle A, B, C, D to the left side. So if you push that, then what you get? So this CD, so maybe here, and AB will be here. So then we are getting a new. So let's say this is E and this is F. So now here interesting thing that the area, this part, this part, if you cut it and put it here, it will feel. So if you take this FCD, this area, and you put it on the AEB, then it will fit on this AEB. So this means, the area of EFCB is the same. It will be the area of ABCD, the place inside of Y. So that's why now see, if you know this A and if you know this is, let's say, H, so this is nothing but the height of the, this is the height of the parallelogram. So this is the height. So area of the parallelogram, we are getting height into base. This is very important. So if you have why? Because area of a rectangle is, you need to take the product of two dimensions, length and breadth. So A into H, and this area is nothing but area of the parallelogram. So H into A, right? Okay. So now once we know the area of a parallelogram, we can calculate area of a triangle. So let's say if we take a triangle, so see one thing here, observe that all time we are just using the side length to define area, I mean boundary. So that is very important, because we only can measure, we have only the machine that used to measure is the length. So somehow that's why we are using the concept of length to define the area. Okay, if you have a triangle ABCD, then and we want to calculate the area. So now here observe that basic idea, if you use, just take ABC triangle and put it here again. So this is nothing but B, right? So just you can say we just reflect along the AC line. If you reflect ABC along AC line, then maybe this way, this is called B dash. Now see, this is a parallelogram. If you have and this total parallelogram area, we know how it is defined. So if you know the base and if you know this height H, then the area of the parallelogram is A into H. Now since the area of the triangle is the half of the area of the parallelogram, so area will be area of the triangle basically half into height into base. So that's why in the school and okay, you learn that area of a triangle is half into base into height like this. Okay, now the interesting one more. Okay, one more easy. So this is a triangle. Now let me give you the trapezoidal. So if you take a trapezoidal, then what will be the area? So let me take a trapezoidal here. So trapezoidal, how defined? So two sides are parallel and another two side nothing. No information given. So let's say parallel side A, B, C, D is a parallelogram where AB is parallel. Sorry, AD is parallel with let me write it here. So AD, let's say parallel with BC. Now what we try to do, basically we want to calculate the area. So let's say this length is A, this length is B. Now what you do? So now somehow we know so far area for triangle. So what you can do here, basically you can join B to D. Now see, now interesting fact that the area of this parallelogram, so area equals to the area of this triangle ABD plus area of the triangle BCD. Now look at this. What is the area formula for the triangle ABD? ABD, if you take now this height, this, if this is called H somehow, this is height of the parallel sides of the trapezoidal. So half into this will be the height of this and the base is A. Plus similarly BCD, if you take, then height is H, the same height, right? H, this one H also into the base B. So what we are getting? We are getting half of H, A plus B. So this is the formula for the trapezoidal if you have. Now it is interesting that if you have something, if I give you something very complicated image and ask to calculate the area of this complicated region, so which boundary are the finite numbers of segment, then you can calculate easily area. Somehow you will try to break it into the small triangle. So something like this, maybe this way triangulation, you can do it here. So maybe this way, maybe this one, and the area of the triangle and rectangle. So you can split it into the small triangle and you can calculate the area. You separately you calculate the area of every small triangle, add them, then that will be the sum will be the area of this given region. But now the interesting fact comes when we take a region whose boundary are not the line segment, are the curve. So then how we defined? Then how we can define the area inside that type of the plane region. So to do this, we need a new advanced tools that we call the calculus maybe. So this calculus is a branch of mathematics where we will deal with small quantity, very small quantity. We will make accuracy of error and we can estimate error. All these things we will talk in this calculus course. If so what actually this is, this calculus invented many years ago by Archimedes to study the area. If you have something, this type of situation, boundary is the curve, then how much area inside that curve, that they want to understand. Basically, he started with circle, and at that time he invented like pi, all this thing. So that is history. Right now, actually, math, these are the very basic. But if you know this history, so you will be motivated and somehow you get a energy to study the higher math and also the abstract language needed. So like, mathematics is like a song, daily life you are talking in the normal language, but if you use logic and little bit voice up and down, then this is called song, right? So that's why, mathematics also like this. You have lots of idea. Regular you using numbers, like you go to the shop, grocery, everywhere you are using the numbers. But if you think and give little logic, then it will become mathematics. And makes life beautiful. That we will do here in this course, and we'll do rock. Thank you, everyone. Bye.